Hi there guys, welcome to the second Genome2D tutorial. We will start right away where we ended in the previous tutorial. As you can see, I just added a few additional assets. This will be our movie clip assets. Just to save some time, it's an XML, it's the atlas definition and the PNG file for the atlas itself. So let's start with a few changes. We will create a function to create our crate sprite. So we can create more of them if we need it. And let's look at the atlas creation process. It's very similar. It's the same, just a different factory as the creation of a texture. So it's a G-texture atlas factory. Create from assets as usual. We need a unique ID. It's a little bit different from the texture ID because atlas itself it's not really a texture. It's a group of textures. But you can access it the same way as textures using its ID, and you can also access all its subtextures using their IDs, and their IDs will be generated from atlas ID and the IDs defined in the mines XML. So let's say we want to have a mines atlas ID. The bitmap asset is mines GFX and the XML asset is mines XML. This will create the mines atlas and all its subtextures and upload it to the GPU. It will upload only this one PNG to the GPU and define the subtextures using the UV coordinates within the whole region of the texture. This is used to speed up rendering because we can have quite large amount of graphics inside a single GPU texture, and just using the region lookup to render a part of the texture that we need, so we can batch more draw colors together. Anyway, to look at the atlas definition, it looks something like this. Let's wait. Okay. It's created using the texture packer software. You can download it at texturepacker.com. It's a commercial software, but you can try the trial. It's a great software to speed up the workflow because I don't think anyone wants to do this manually. So as you can see, all these subtextures are defined by name, which is the ID in our case in Genome2D, and the region where they are contained within the large bitmap. There can be additional properties like pivot and other stuff, but we are not going to delve into that now. So, as I said, if we wanted to access a specific texture from that atlas, just for example we want to render just one of the subtextures inside this sprite, we can access it simply by mines, which is the ID of the atlas, and underscore and mine1, because that's the ID of the first subtexture. Okay, let's use 2 because it's more visible. The mine1 is, I think, the whole black. Anyway, let's start this up. Oh, we need to create the create here. Let's specify our position. As you can see, instead of the create texture, we see the mine1 texture from the mines atlas. If we wanted to store the reference, we can do that as we could with the gtexture factory. Simply the atlas gtexture atlas. We can do the same by lookup for the static, using the static method in the gtexture atlas. Gtexture atlas by get gtexture atlas by ID. This will look up for this specific atlas. As I said, it's a unique ID, so we can do this anytime, anywhere. If we wanted just a specific texture from the atlas, we can do that with a bunch of different methods. For example, we can use gtexture get texture by ID. This also looks for subtextures. So pretty much any texture. It will get us the create texture, but it will also get us any subtexture from the mines atlas. So mines underscore mine1 or mine2, doesn't matter. Any of the, it will not get us the atlas because atlas is not the gtexture instance, but it will get us any of the subtextures. We can also get it from the atlas itself. So get texture mine1. As you can see, we don't use the atlas ID here because we are getting the texture directly from the atlas reference. So we only use the subtexture ID from the atlas definition. Okay, now we are going to use this atlas and create our first movie clip. We are going to create mines. Mines because that graphics is actually from one of my games. It's a Minesweeper clone, so it's very nice to showcase a movie clip because those are just rectangles with numbers. So let's define ourselves a position, and I'm going to use a different method to create a node with a movie clip component than I used here, because we don't need to use the factory method like this. It's up to speed up creation of instances if we want a node with specific component, but we can create it in a succession. We can create node and then add the component, because some people, if once they see this, think that one component or one node means one component, but that's not true. A node can have any number of components. So let's create ourselves a node for our movie clip using the factory method for creating just the node. We can specify a name here. It's the same like in native display list. It's a name of the movie clip. If we don't specify it, it will be created for us, something like gnode number 100 or something. It's not unique, same as the native display list. And now, once we have the node, we can create or add, to be more precise, add a gMovieClip component to that node. Oh, movie clip. As you can see, there are more parameters here, but we are not going to delve into them now. It's to differentiate the actual component class and the lookup class for the component. It's quite advanced topic. Okay, once we have our movie clip component, we can set the texture atlas. It will render. It's the mines atlas. Again, we are using the texture atlas ID, but we can use the direct reference to the atlas if we want to avoid the lookup. I'm going to use the IDs because it's simpler. And one more thing, the texture ID properties, like texture ID, texture atlas ID, and sprite texture atlas, stuff like that, is very useful for level editors and stuff, because we can easily save this to an XML and read it and set it back again, because if we wanted to, let's say, save the texture reference, we can't do that. We would need to look up the texture reference and save the texture ID, and this will speed things up if we want to parse and save text data. Okay, we have the atlas set. Now we add it to root. We can use the node directly, because the node has the gmovie clip component. We can also do this. It doesn't matter, because this refers to this node since it's added there. Okay, we can create mines at stage width, a little bit offset it from the center. Now I'm going to run it, but it will not render anything. I'll tell you why. This is our crate, but we don't see our movie clip here. Okay, let's set the crate back to the crate texture, just for so it's clear. Why doesn't it render anything? Because we didn't specify the frames it should render. Okay, because we can have an atlas with like 5 animations, and we didn't specify which of the animations we want to play. Okay, we can have an atlas with single animation, but it doesn't implicitly set the frames to all the atlas IDs. Because, for example, even if we did have a single animation, it's not always that the animation is 1, 2, 3, 4, 5, 6, because the IDs can be reversed, they can repeat. So we need to specify the frames it should render. The frames, sorry, it's an array of string instances. Is the IDs it should render. So let's say we want to render 1. Those are the IDs of the subtextures inside the atlas specified here. We don't need to specify the mines underscore, because we always need to have the atlas specified. Unless we don't have the atlas specified, it will not render anything, even if we set the frames. So mine 3, mine 4, and now let's run it. Okay, something's not right. Let me check. The thing is, we didn't set the position here, so we need to do so. Now we will have our movie clip on the correct coordinates. Okay, as you can see, it changes there quite fast, over and over again. We can set a speed for the movie clip. It's per movie clip, so we can have 10 movie clips and each of them can have a different frame rate. This is going 1 frame per second. The default frame rate is 30. Let's add ourselves a few more frames. So what we can do with the frames, there is no internal support for these kind of animation collections. It will be added probably later, but we can change it on the fly pretty easily. So let's say we wanted like 5 different animations. We can create ourselves a dictionary with the like walk animation with these IDs, and then attack animation with different IDs, and then just change this on the fly. It can be changed anytime. We can also repeat frames very simply. This means that the mine1 frame will play 3 times before the mine2. As you can see, it's there for a longer time. The mine1 is the empty one. We can also repeat. We can have different, instead of consecutively, we can go from the 8 to 1. Pretty much anything is possible here. Yeah. Because most walk animations in real assets don't reuse frames, so it would be like 1, 2, 1, 1, 3, not 1, 2, 3, 4, 5, and we don't want to waste memory by having the third frame on GPU if it's the same as the first frame. So, this node, this movie clip, since it's of the node, can have all the same transformations as the sprite. Pretty much any component will have the same transformations, because this transform is a component of the node. It's not related to this sprite, which is just a renderer. So any node, since we add the movie clip renderer to different node, that node can have the same transformations as we showed yesterday, like the scale and rotation and translation and all that stuff. So let's look at something entirely different, like mouse events. Let's hook a mouse event to our sprite. We need to do few things. The mouse event is always hooked to the node, not to the component. You can have the component itself handles the mouse events, and then sends these that there was an interaction to the node, and the node will let the user know. But we don't want to add the listeners directly to the component. It doesn't make sense. So, because it would be funny if 2 different components on a single node had different reactions to the mouse event. Also, a node can have any number of renderables. A renderable is a specific component that use the render methods inside it. There was a limitation in earlier versions of Genome2D that you could only have one renderable component on a node. Now there is no limitation, but I wouldn't advise to use like single node with movie clip and sprite on it, because what's the point? I mean, I don't see any. It would be always way better to use two nodes. But if anyone wants to try it out and knows a use case where it's handy, just let me know. So back to the mouse signals. It's not the events. So let's say we want mouse over on this crate. And mouse out. Now defined. I know that Flash Builder offers some kind of fast prototyping for the method creation, but I'm not familiar with it, and I always use the manual approach. So this signal has a parameter in its callback, and it's the G mouse signal, which will contain all the information about the signal we cached, similar to the mouse event. And we also need to say that this node will catch mouse events, because mouse enabled in Genome is always false by default. I don't know why this playlist always has it by true by default, because it's a huge waste of performance and most people don't disable it. So I decided to always have it false by default, and if you really want some mouse interaction, you are probably hooking events on it, so you will know that you need to enable it. If a parent of this node, the root, doesn't have mouse enabled, it doesn't matter, because it has the mouse children, which says that it will process the mouse event further to its children, but it will not handle mouse itself if it doesn't have mouse enabled. And mouse children is by default obviously true. So let's say we want to change the crate on our mouse event. As you can see, we don't have the sprite nor its node defined as some kind of property or a global variable, so we need to get into it inside this signal callback. So the signal parameter will return the dispatcher and target properties. One of the dispatcher is the original node that dispatched this signal, and target is the current node that dispatches. It's similar to target and current target in this playlist, because the signals bubble in Genome2D. So if we have like root, parent 1, parent 2, parent 3 and node, the node, and we listen to the node, it will dispatch the signal, and the parent 3 will dispatch as well, but parent 2, parent 1 and root. So we can listen to the, let's say, root for a mouse over, and we will get the signal from this crate, so where the dispatcher would be this crate node, and the target would be the root. But now, since we are listening directly on the node, so the dispatcher and the target will be the same. So dispatcher is our node, and let's change its transform, or red, or no, let's say we want to change green to 0, and on mouse over we want to change it back to 1. Let's run. As you can see, it works. We are changing the color of the create node. It's pretty simple. We can also tween it, but there is no internal tweening in Genome2D. I always use Tween Light from GreenSock. It's great. You should try it out. I don't have it ready yet, but I will use it for later tutorials. Okay, we can try another mouse events, for example, click event, which is nothing more than down and up in succession. Let's try it out. As you can see, it's working. So let's try out like 100 of the crates, or 500, doesn't matter, we can, or 1000. Let's create them at random. All of them will have the mouse handlers, obviously, since we are using these methods. So let's try it out. As you can see, the mouse events work perfectly. What it does is hooks the stage mouse events on the native display list, and then goes through its own render graph and all the collisions to check out for the correct hierarchy information and overlapping. Anyway, that's too technical. And there is also support for pixel perfect mouse collision, because the sprite in itself, it's just the quad. It's always a quad, even if you don't see if you can see a ninja or something else. But internally, it's a quad with the alpha 0 pixels around the ninja. And if you didn't enable the pixel perfect mouse, it would handle events on the empty space as well. We can show it. I'll try to look for my ninja assets. Let's wait a little bit. Okay, there is my ninja. We will swap this out for a ninja. Oh, we can leave these names like they are. This will create a ninja, but we need to specify, since the ninja subtextures have different names, we need to specify those. they will no the animation will not be correct because I'm just trying out, but I don't know the exact animation sequence. But doesn't matter. As you can see, there is our ninja. And now, if we used all this on our movie clip, oh, we forgot to enable the mouse for the ninja. It works, but obviously it doesn't have any blue. So let's try red. Oh, as you can see, it works. And now we can see that I'm over this part that doesn't have any alpha, so it's not really a part of the graphics from user standpoint, not from the genome standpoint, but it is actually this kind of quad that handles the mouse events. So it will fire a mouse event correctly, but we should ignore these 0 alpha places. So to do that, we can specify node dot node. It's on the renderer now. So clip mouse pixel enabled true. And now, as you can see, it will only fire the mouse event even only for the correct pixels that have alpha non-zero. It also works with hierarchy, so we create um, 1000 ninjas. It will work. Let's speed them up so they all. As you can see, they all play from the same frame. We can change this just for fun to go to frame mat random. Since we have 6 frames, let's do 6 or 5. Now all of each will start in different frame, but it's too fast anyway, so we don't see it. Let's bring it back, and we'll only 100 ninjas. As you can see, each of them plays from a different frame, and there is our crate. So that's all, folks, for now. I'm hoping you learned something. Next time I will probably talk about components and how you can create your own component and add it to a node to do something. So any feedback is welcome, and thanks for listening.